G is positive, that means it's thermodynamically unfavorable. So if delta G is negative, that means it is thermodynamically favorable.
Golly, why is that?
What do you mean?
Why is it negative and it's favorable?
Because you have basically, all right, if it's negative, then that means you have excess energy that can do something else. So if you have energy that's available to do something,
If you've got extra stuff, why is it not positive?
it's just a sign indication. Why is delta H being negative mean that you're releasing energy?
Hey, are you going to be a chemist?
It just is.
No.
But it doesn't matter.
Okay. All right. So the equations for delta G.
That's my kind of science.
Equations for delta G. First is the not the granddaddy. Big Mama equation. Delta G of the reaction, sum delta G of the products minus sum delta G of my reactants. Again, just like here, multiply by coefficients. Another equation relates delta G to electrochem. So, delta G equals negative N phi. And we're going to talk more about this when we get to electrochem, which is the next one. The third one is relating delta G to equilibrium, negative Ratlink. Here's the biggest thing here, okay? For both of these, okay, you have to watch your units because this delta G that you calculate because of this right here is going to be in joules, so you have to convert. Okay, so you have to convert this one to kilojoules.
What does that say going with the star?
Watch units.
Okay.
All right. Most of the time when you use this equation is when you're going to find K. So this R that you use is 8.31. The problem with that is that's in joules. So what do you have to do with delta G?
I convert it.
Convert it to, or convert this, right? So I always like to just convert to kilojoules. You have to get this and this in the same unit to solve for K. Are you all right with that? It'll be 0.00831. Yeah. When you solve for delta G, it will be in joules. So you have to convert it to kilojoules. What is a megan? Why? Yeah.
Do you convert the 8.31 or the whole thing?
I convert the 8.31. Now, when I do that, is when I'm solving for K. Or to get this in kilojoules, you have to convert. So just always, when you use this equation, call this 0.00831. This will be in kilojoules, therefore. And then your K, if you solve for it, will be the same. Okay, yeah.
So if you convert with the R,
Uh-huh.
if you convert that, could you convert and wait to do G after you like solve it all out, and then convert it, or is that gonna mess it up?
Okay, if you're solving for G,
Or delta G?
if you're solving for delta G, and you convert this to kilojoules, then your answer for delta G is already in kilojoules, so you don't have to do anything at the end. Does that make sense? Yeah, gotcha. All right, so now let's let's look at the very fourth equation, and this is the biggest equation with delta G, the one you'll use the most. This is the granddaddy equation. Delta G equals delta H minus T delta S. This is the biggest one where you lose your points on because units, right? This delta H is in kilojoules. This delta S is in joules. So what do you have to do? Convert your delta S. Convert to kilojoules. Please don't forget that. That's an easy way to lose points. So now let's look at sign conventions. Remember, sign conventions are huge, especially in multiple choice. Okay? And this all comes from delta G equals delta H minus T delta S. All right. So, if your delta H is negative and your delta S is positive, then your delta G will be negative, thermodynamically favorable, always, no exceptions. If your delta H is positive, your delta S is negative, then your delta G will be positive, always, with no exceptions. When these are both the same sign is when you have to factor in temperature. So if both of these are negative, the only time when delta G is negative is at low temperatures. At low temperatures only is when delta G is negative if this is the case. Yes?
What would like low temperatures be?
Low temperatures would be like around 298, 300 Kelvin, something around there. Higher temperatures would be probably around the 400 above range. If both delta H and delta S are positive, then you will have your delta G to be negative only at high temps. And those are your sign conventions. One more thing I have to go over and we're done with thermo. Okay? And that's your phase changes.
I know this.
I know this? Good. You want to do it?
Yes, teach it.
Nuggets, teach it.
Go. One thing. Go. No, I'll push her over. Wait, this is the thing with the chart, right?
Gas, solid.
Yeah, I know. No, not this. Is this a try? Is this the only?
This is the triangle.
Let's fight.
Okay. Now, this is when you have your phase changes, all right? Now, phase changes can be exo or endothermic, okay? And another concept you need to know, when I have a phase change, my delta G is 0 because I'm at equilibrium. Anytime you're at equilibrium, your delta G is 0. So that goes for any time you have a phase change. Now, which state of matter has the highest energy? Solid, liquid, or gas?
Gas.
Gas. Very good. So highest energy. And therefore solids have the lowest energy, right? Okay. So the rule here to figure out if my process of a phase change is endo or exothermic is whether or not I'm going to a higher energy state or a lower energy state. Anytime you're going to a higher energy state, so that's a solid to a liquid, a liquid to a gas or a solid to a gas. I'm going to a higher energy state. So if I'm at a low energy state and I have to go to a higher energy state, do I have to put in energy or do I have to take away energy?
Put in energy.
Put in energy. And Megan, what is that? Endo or exo? Putting in energy is endothermic. So, going to a higher energy state is endothermic. All right. What about if I have to go to a lower energy state?
Exothermic.
Exactly. So a gas to a liquid to a solid, or a gas to a solid. Those are going to a lower energy state. So those are all exothermic processes, whatever. You guys okay with that?
No, but we will be.
Thermo in a nutshell.
Good as I'm gonna be.